Hi, I'm Patrick Kennedy, Editor-in-Chief at Serve the Home.
Gopal Hegde, I'm the VP GM of Data Center Processor Group at Cavium. Yeah, we've been working with Patrick for last 3 years. He did our first generation platform benchmarking, and we just announced general availability of ThunderX2 processors in May at an event in San Francisco. Patrick was kind enough to actually participate in the event, and he talked about his experience with ThunderX, compared and contrasted that to ThunderX2, and then he also talked about some of the performance benchmarks. Then he published a very detailed performance benchmarking article which covered various aspects of the platform, not just the performance of the platform, also ecosystem, platform readiness, compared to how his experience with ThunderX was, and not just the processor performance, but also performance at a platform level, including storage and I/O.
So how's the performance?
It's awesome. So this ThunderX2 platform is significantly faster than the first generation ThunderX1. You now have 32 cores per socket and up to 128 threads per socket, so 256 threads in a single server. The other side to it is that these cores are much faster than the original ThunderX1 cores, or ThunderX cores.
So the single thread is...
Single thread performance is higher, multi-thread performance is higher, and then beyond just the CPU performance, Gopal mentioned the platform performance, so we also looked at performance using storage class memory, so Intel Optane, as well as NVMe SSDs. The performance with ThunderX2, they're actually able to handle multiple devices at once, and then we looked at networking performance all the way from 10 gig up to 100 gig networking, and this generation is able to handle even the high-speed networking that's demanded by today's enterprises and cloud players.
So you said general availability, so until now it was just trade shows?
So until now we were sampling the part, and we had a number of customers who had actually developed platforms based on the chip. We have demonstrated those platforms at various trade shows. Those platforms were shipped to end user customers mainly for evaluation and software development. So in May we actually announced the production availability, and now the customer platforms that are shipping in the market will have production silicon, and we are ramping production of this part in volume.
So when you say production silicon, that means you basically tweaked it and optimized things until May. And then May, it's not the same performance as the previous demo prototypes that people had, right?
Yeah, exactly. So not only did we improve performance, we also improved power. In addition to that, the firmware and all the software and everything that goes around the chip was also brought to production quality. So all the pieces are now available for people to actually build platform with this chip and sell it to their customers, or for the end user customers who are deploying platforms in their applications, they can actually now use the production qualified parts from us. Typically it takes about a year from the time we sample to take the platform to full production, and during that period people actually do the development, platform development, they do platform qualification, and they do software tuning, and then they take it to production.
So was it around a year?
Yeah, it took about a year, yes.
Is last Computex?
Yes, in last Computex we started showing some early platforms based on ThunderX2. Those were prototype platforms. Those were using prototype silicon. We had a A2 rev of silicon in them. Now the production rev is B1, and it is fully qualified part, which is production ready.
And that's also, I'm guessing, optimizing in the kind of like in the fab and all the design around the manufacturing of the chip.
Exactly.
The yields are great. There's no issues and everything.
Exactly. Right. So we go through full production qualification. We qualify all the IOs on the chip. We also optimize yield. We look at various process corners to make sure that we can actually have very good yield. We optimize for power. We optimize for performance. In addition to that, all the software that needs to run on the platforms gets taken to production level as well.
I'm guessing this is the biggest ARM processor ever, so it's got to be a lot of stuff to check out and smoothen out until production, right?
Absolutely. It's not just about the chip. It's also about all the software. It's also making sure firmware is there, making sure OS support is there, tying it with Canonical and Red Hat, okay, and SUSE support, etc. So, for example, in the supercomputing, Red Hat announced production availability of their operating system on HPE's platform, okay. So it required a production quality platform in order for them to certify these systems. We just achieved certification on Ubuntu very recently. So customers now can use Ubuntu Canonical and then get support on the ThunderX2 production platforms from Ubuntu. Same thing with Red Hat, with Select OEMs and SUSE. So he started with the production silicon platforms.
So you started
I started with production
Production.
silicon.
in May.
Right.
So last month.
Probably April, I think.
Yeah,
we
he started in April,
Yeah.
right? The event was in May, right? It took us about 6 weeks to actually get through all the benchmarking, right? That Patrick did, and for him to publish the article, right? So he had production ThunderX version in 2016, and he benchmarked production ThunderX, our first generation ARM server, in April, May, June of 2016. And now 2 years later, he's benchmarking our second generation ThunderX2 production systems, and they're both from Gigabyte, okay? And you can actually ask him about what his experiences is from an ecosystem standpoint, platform readiness standpoint, etc., not just on the performance.
So is
Yeah.
it one of those?
Yeah, it is. So, if you look at this server, I don't know if we can pull it out a little bit further, but this server is actually really interesting because this is very similar to the Intel and AMD EPYC servers that we review for Gigabyte. You'll see some features such as an A-speed BMC, which is the industry standard in terms of baseboard management controllers. You'll see industry standard IPMI in these systems, so you can manage them alongside fleets of traditional x86 servers.
So how do you get one of these, and how do you start doing the benchmarks and stuff? Do you just plug it in and start installing software? What do you do?
Yeah, so the this generation is certainly a massive difference between when we started with ThunderX in 2016. The overall operating system installation, software installation, and ecosystem readiness is significantly beyond what we saw just 2 years ago.
So 2 years ago, you had to fiddle around with hacking some stuff and trying to make it work. Now it just works, or?
Yeah, so there are a lot of packages that were not compiled and installable via package managers and optimized packages in package managers in 2016. Today, you see these systems install OSs right out of the box. They perform well out of the box, and so the barrier to entry for DevOps teams being able to use these ARM servers compared to where it was just 2 years ago, these are certainly ready to go into production today.
So did you work with the Ubuntu, the Red Hat? What do you do?
We did use Ubuntu, yeah.
Ubuntu?
Yes.
And what did you test? What do you test the whole thing, everything? What did you benchmark?
Yeah, so we have a series of benchmarks, both for CPU performance. We have memory performance benchmarks like Stream. We also went and did networking and storage performance benchmarks. So the result is that the performance of these systems are certainly on par, if not in some cases faster than AMD EPYC and Intel Xeon Scalable, gold level processors.
So the gold is the right one to compare with, because there's different ones.
Yeah,
they
so
have some higher ones, right?
yeah,
but
they
they're
have-
different market, or what?
Yeah, they have Xeon Platinum, and Xeon Platinum, does cost a lot more. It's also, I think, targeted more towards 4-socket and 8-socket servers. So if you look at something like we used specifically in our review, we used the Intel Xeon Gold 6148 set to compare to the Cavium ThunderX2.
Let's just jump over there just 1 second. For example, just to compare what the AMD has on the market, what's the fastest AMD has, and how does this one compare?
Sure. So the fastest CPU that's on the market from AMD is the AMD EPYC 7601, which is also a 32-core processor. Only has 64 threads versus 128 with the Cavium ThunderX2. It's x86 based and has 8 DIMMs per socket. One difference between what ThunderX2 has versus what AMD has, that's important is that the AMD EPYC CPUs use 4 NUMA nodes because they have 4 separate die on each socket, which is different than traditional Intel Xeon systems. ThunderX2, in contrast, uses a single NUMA node, which is more analogous to what you would see and you'd be accustomed to on the Intel Xeon side.
What is this Luminode, you'd say?
NUMA node, so
Yeah.
it stands for non-uniform memory access, and essentially you can think of it, in this case, easy way to think about it is the number of DIMMs that are attached to a single die without having to go over an interconnect to reach those DIMMs on a different silicon die.
But so AMD and Intel are doing the complex chipset, right? And you're doing reduced interrupt. Does that mean you can still do everything
Yeah,
that
absolutely.
people want?
Absolutely. So the RISC versus CISC matters only at a CPU architecture level. For application developers, the code gets converted to machine language. Okay, so whether it is a RISC or a CISC machine language, for application developer or for a user who's actually developing code in higher level programming languages, doesn't really matter. Where RISC benefits is that RISC actually has fewer instructions, which means it's less complex to build, and then overall power consumption does have benefits, and that's one of the reasons why ARM processors have traditionally been low power and they have focused on that market.
So did you notice anything missing, or do you think people that need to do what they need to do will be able to do everything they need to do on this RISC-based ARM server?
Yeah, so for certain workloads, I think that the Cavium ThunderX2 works really well, especially if you have control of your source code and are able to compile that source for ARM servers. If you have closed source or you don't have access to your source code and it only runs on x86, of course it won't work on ThunderX2 at this point. But if you do, if you're just running an Nginx web server, for example, or you're running an HPC application where you can download that source code and compile it for ARM, it'll work out of the box.
For example, right here behind you, there's something about the MySQL. So how is that performing? Did you do tests about that?
We did, and that's going to come in a future article. So that was not in the launch piece, but we're going to have a follow-up article in a couple weeks. The MySQL performance is certainly competitive, if not better in some cases, than Intel Xeon Scalable.
And all this stuff people do on the cloud, what's it called when you have PHP and all these Apache, what do you call it, Apache?
Like a LAMP stack? Is that
LAMP
what you're
stack,
thinking?
the LAMP
Yes.
stack, how's that doing?
Installs easily using package managers. So if you were to go follow a standard guide that you'd find on the internet, and you're to use package managers to install the software to work just like
And the
an
performance?
x86. Works great out of the box.
Great out of the box. So which of the applications are really better compared to Intel?
So the ones that work really well are those that are compiled using GCC. Cavium uses GCC as their standard compiler. GCC is also the most popular compiler in the market because it's open source and everybody has access to it. So they perform very well when you compile your software using GCC. In terms of actual benchmarks, a lot of the HPC benchmarks work really well. Stream benchmarks, so memory bandwidth, is something that the ThunderX2 excels at because it has 8-channel memory versus Intel Xeon Scalable, which only has 6. So there's an immediate benefit there.
And how about over here? Is this storage related stuff around here? How's it going with storage?
So this is Cassandra. It's a NoSQL database application, right? So this is actually pretty popular by a lot of the cloud guys. And what you see here is performance of Cassandra for throughput and latency compared to Intel, and actually the performance is very competitive on Cassandra. So we have customers actually using this. So what you see here is some of the application benchmarking and applications running on Cassandra, and this actually uses the Micron NVMe drive, and we worked with them to actually demonstrate how well the overall platform performs. And as Patrick mentioned, he did the performance benchmarking with NVMe drives as well as a part of his article. and overall from a performance standpoint, we're extremely competitive. We are able to keep up with the high performance storage and networking capabilities required for servers.
So without saying who the secret customers are and everything, would you say that companies that do cloud, let's say the Googles and the Facebooks, like it's a no-brainer, or because the main advantage here, is lower price, right, than an Intel system? Is that true?
Well, it's lower price. Also, I think a lot of those companies are looking for supplier diversity. So instead of just using Intel platforms, they're looking for an additional supplier to lower their risk and also drive greater performance in their platforms. And so from that perspective, ThunderX2 is able to go into their ecosystems in a dual socket platform, which is analogous to what they would have with Intel Xeon. They're able to connect high performance NVMe drives, high performance networking. They're able to get per socket performance that's on par with the x86 solutions. And so, if you are a cloud provider, if you are an HPC vendor, I do think that ThunderX2 is able to be competitive.
How about the price of power? There will be some savings?
Now the power is actually very similar, right? So our TDP is similar to x86, and it actually allows us to leverage the x86 infrastructure very nicely in terms of chassis, power supply, the heat sinks, cooling, everything, right? So though ARM architecture does have power benefits, okay, we have tried to focus much on performance, and we provide power parity to x86 architecture.
But how is the cost of your solution compared to an Intel one? Is there some savings in actual
Yeah,
hardware?
absolutely. So I think if you look at some of the what we announced at the GA event, we announced 2 to 4x total cost of solution benefit, right?
2 to 4x.
2 to 4x at a processor level, and a lot of it is driven by processor pricing and the overall performance of the processor relative to application.
So what's the price of a processor?
So our GA announcement called out the volume SKUs priced from $1,795 at the top end, all the way down to I think $800 at the bottom, and we gave a number of SKUs, and we actually mapped all those SKUs to various x86 SKUs based on performance and power.
So you're talking about half or a quarter of the price just for the chip,
Yeah,
but the rest is
similar. Yeah,
Rest is
exactly.
similar, but the chip is a big part of the cost. Let's look at this for example. If you have one of these, there's 2 chips,
Yeah.
and then there's all this other stuff. But what's the difference in price for the whole
So chip
thing?
is roughly depends on the configuration, right? So in a storage box, obviously the price is different compared to more like a compute box. But in a compute heavy node, it could be 25 to 30% of the platform cost, just the processor itself. Okay, so if we save less than half on the processor pricing, overall total cost of ownership for the platform goes down. And if we deliver better performance for some applications, that means you need less of the ThunderX2 servers compared to the Xeon Scalable or AMD EPYC, in which case your TCO benefit actually multiplies.
Are there any benchmarks where this ARM server is just way ahead?
So there were some benchmarks published by Professor Simon McIntosh of University of Bristol as a part of his GW4 program, and there is a presentation in Cray user group that he made where he's actually showing a TCO benefit anywhere from 2 to 4.4x. And for some of the applications where memory bandwidth is a key driver of overall performance, our performance benefits are significantly better, and that actually translates it into overall TCO benefit for the customer.
So between 2 to 4.4 in terms of
TCO, total cost of ownership benefit at a processor level.
for the processor. All right. So it was fun to benchmark this platform.
Yes.
Yeah, and it's very exciting because I've been doing ARM server videos for 7 years, 8 years now. So are you saying it looks like it's ready for prime time, right?
Yeah, so if you compare the ThunderX2 servers of today to what a lot of the development community had been using before, which is something like a Raspberry Pi, for example, this actually has full IPMI functionality. It looks and feels as you're using it much like a traditional x86 server rather than a much smaller unit that doesn't have all the features that you would get on a small development board.
And you have still all these different SKUs, and they're all available. The ones that are more for storage, the more for networking, the more for
Yeah, absolutely.
So
we actually have roughly 40 different SKUs.
what do you say?
40.
40.
Yeah, and they go from top end 32 core 2.5 gigahertz, which is sort of a premium SKU. Our 32 core 2.2 is where our volume SKU starts. Goes all the way down to a 16 core 1.8 gigahertz part, and these are available at different price and power. So, for example, at the low end, our power is 75 watts for a 16 core 1.8 gigahertz part, and it goes all the way up to 180 watt 1795 for a 32 core 2.2 gigahertz part. So different SKUs targeting different applications and different power and performance points.
So is this an exciting time right now? Like
It's actually very exciting. I mean, I think Patrick's article was very well received. A lot of interest from a lot of customers. Very very detailed benchmarking that he did. We had a tremendous traction at our GA event. We had over 40 articles published on how competitive the platform was. A lot of positive press out of this. We had over 8 customers who actually presented at our GA event, including customers like Microsoft, HP, and Cray. We had over 20 partners who were actually present at the event. Many of them were part of the partner panel. We have over 60 partners now, and when we started 4 years ago, we had 2. So we've come a long way. We actually have a very good high-performance platform now, ready for prime time.
nice, and all this exciting stuff happening in the industry where maybe there's going to be some additional forces in your organization, I'm guessing, because of I don't want to ask what's going to happen, but it's going to hopefully just go crazy in the end of the year. It's going to be
I think
lots of huge data centers.
Well, we're keeping our fingers crossed and stay tuned on how this goes.
And you'd like to benchmark the next one?
Of course.
That'd be cool. All right.
Yeah.
All right.
Okay.